Good afternoon, ladies and gentlemen. This is a talk about test-driven development, and we need to start fast because I got 96 slides and a lot of code. My name is Jakub Nabrdalik. I'm a team leader at Allegro, and I'm not a very interesting person, so if you need any details about me, this is on this website. From the perspective of this talk, the only important thing is that I do test-driven development since 2005. So that's quite a lot of time right now. And apart from doing a full-time job as a team leader and a developer, I also work with other teams. But before I give you any advices on actually how to improve something or best practices, you always need to ask the person what is their context, because maybe their practices and their experiences do not apply to you. So I work for a company which has got more than 700 microservices and about the same number of developers right now. So one microservice per developer, which is neat. And we usually work with all the languages, to be honest, all the popular languages except for .NET. But the base of the system is actually built around Spring. So my examples are going to be in Spring and using a Spock framework, which is one of the best testing frameworks. But you can apply all that knowledge to other technologies as well. Apart from a full-time job, I also, because I do not have kids, so apart from a full-time job, I also have another job, which is I do workshops with a company called Bottega in Poland. And I give workshops to companies and to teams. And I see a lot of teams actually having problems and the kind of problems that they have. And this talk is based on my experience with what people do not understand and what they are struggling with. So I have to start with saying that there is a great talk about the philosophical aspect and the different approaches to testing by Sandro Mancuso, and you can watch it right there. And if you are if you are on a Shuhari of levels 2 and 3, then most likely you would like to watch that talk. Now, for this talk, I'm assuming something completely different. For this talk, I'm assuming that you have some experience with test-driven development or tried test development and it didn't work too well, or maybe it's like you were promised a beautiful ride, but you feel like some shit is thrown into your face, right? So let me clean that up a little bit. What that means is that I'm not going to sell you something that works 100% of the time. But if I can solve that problem for you for 80% of the time, that's great, okay? So what are the typical problems that teams and developers have with test-driven development? And the first problem, which is very common, is that we are testing too low. Most of the people, when talking about unit testing, think about testing classes or methods. And this is a no-go, to be honest, with normal business applications. And the reason for that is that this is a diagram of my production system, by the way. And as you can see, each class has got a lot of connections and interactions with other classes. So how do we do that with test-driven development if we want to test a single class? We would add a lot of mocks, right? Now, the problem with adding a lot of mocks is that whenever now you're changing the behavior of the class or the API, or most likely when you're changing the behavior of a single class, you are changing also the API of that class. And all the interactions of that class change together with it. So what it means is that if you ever have a situation when you are changing a single class and 500 tests are now red because of that, you are testing too low. And I had that situation. I actually had to leave a company because I had so many tests that I couldn't write anything anymore. So that doesn't work too well. And the other problem, apart from this, is that even if you have 100% code coverage on testing the classes and methods, your system will still not work on production because those classes and methods do not work together, right? So what happens is that a lot of people think after having some bad experience with unit testing on this level, they come to an idea that maybe the whole unit testing idea is just bullshit, right? Maybe let's just stick to integration tests because they tell you what the system looks like in real, right? And they use integration tests alone. So this is the second most popular problem, which is moving away from unit testing into integration testing, just because it's the only thing that tells you the truth, or so you think. But the problem with that is it's very, very slow. And it will always be very, very slow because it usually works and talks with the I/O. And for example, to give you an example of what I mean by slow, an empty Spring context on this laptop starts in 3.5 seconds. Now, a microservice with embedded Mongo, for example, starts here with quite a few beans, starts in 22 seconds. So whenever I would like to fire a single test, I would have to wait 22 seconds, and I cannot do that. To be honest, if I had to wait more than 1 second for my tests to start, that would be way too long. And the reason for this is that in 1993, there was a research by Jakub Nabrdalik done on the what people think about time. And it turned out that whenever something takes less than a second, you think it's instantaneous. It doesn't break your flow of thought. Now, if something takes more than 10 seconds, it loses your, basically, you're completely lost. You're starting thinking about something else. So it might be Twitter, Facebook, anything else. So when you get tests and only tests on the integration level, the game is completely lost. And what's more, when you have a lot of tests with that, then the kind of a service can go into crazy numbers. Like, for example, 45 minutes before the test finishes. All the tests, actually, the whole test suite finishes. So this will not allow you to do test-driven development at all. So is there any other approach? Is there like a common ground between those two extremes? And there actually is. The common ground and the approach here that I would like to tell you is show you is to actually test your modules. You have your modules in your applications whether you are aware of it or not. Most likely, I hope you are aware of it and you have some diagrams as well, or you are at least thinking in terms of the pictures on the and the modules there. And why testing a module? Well, because a module has got a clearly defined APIs, just like a class has, right? So it's easy to test. A module has got clearly defined collaborators, but what is most important is that the APIs between modules do not change as often, because this is usually the architecture of your application. And architecture of your application changes perhaps once a month, maybe, and that's a slight change. A huge change would be once in a few years, for example, or maybe in a very fast development project, maybe once half a year. So this is the kind of thing when you can start actually mocking the collaborators, and your tests will last. And my modules are usually, because you can approach modules from many different perspectives, but for me, modules are usually the same as microservice candidates. And I actually do that. I create a module inside a microservice, and from time to time, we take them out into separate microservices when they grow, and it turns out they are so big, we can do it, that it makes sense. Okay? And if you are aware of the domain-driven design, modules usually are their own bounded context, which means that they have their definition of a word. So, for example, a user from a perspective of a module of one module is something different than from a perspective of another module, which can have only, for example, user ID, and that's it. So, if you take your modules and test them as black boxes, and unit test them extensively, you will have all flows and corner cases tested in milliseconds. And then what you do, because you also need to test the I/O after all, right? Then you should add the crucial paths that bring money. Not every single test possible, just the tests that will check whether you are still earning a lot of money or not, and put those tests into the integration tests. So how does it work? Let me show you an example and one important trick. Let's say that we have a very old rental application. Maybe some of you remember when we were renting movies, going to a rental place, shop. And we have several modules here. So let's focus on the first module, the films, which has got clear API. From those, composed of those three, actually there are only two methods, right? So what do you start working with? First of all, you need to be able to talk with a module. So we need some kind of an entry point, API, right? So I call this facade, Here we have a film facade. We need to get this, right? But we cannot just create it by calling new. And the reason why you cannot do this is because a module is not a single class. A module is a bunch of classes, and maybe the creation of a module is more complex. So you do not put complex logic inside a constructor. Instead, you have another class, and this is the creator pattern. In Spring, this is usually called a class which has the name configuration because there's an annotation configuration, right? So here I create a new configuration, and then I call film facade to get the facade for the module. Now I create some DTOs, and then I start actually testing the module. And these are only unit tests, right? So I add some movie, I check whether I can get it back. And then I write another test and another test to test as many things as possible, how the module will behave in different circumstances and all corner cases. And these are all unit tests. Now, after I do this, and after I pass the red-green refactor phase, I end up with, for example, classes like here, film creator, film type, configuration, film facade. And I need to have some kind of a database, right? Because this module is actually responsible. We are putting a film in, and we can get the film out, right? So we need to remember those films. So here I have an in-memory film repository. Why? Well, because I cannot touch the I/O. The moment when you touch the I/O, your test becomes slow. So is it difficult to make an in-memory repository, basically a version of a CRUD repository or any other database in memory? Well, it turns out it's very, very simple, and the only data type that you need is a hash map. Because if you do not care about the running out of memory, and basically you do not care about the performance because it's all in memory and in CPU, right? Then you can just walk through the whole stack and the whole hash map and get whatever you want with filters. So at this point, I have this film configuration with a method film facade, where I create a new film repository, other classes that are required by the film facade, right? And the film facade itself. And I have the whole module here, encapsulated here. And this runs very fast, in milliseconds, and we have the code, we wrote the code, we know that it works. Now let's add I/O at this point, after I have all the tests, right? And of course, with Spring, it's very simple. Still, I write the integration spec first. And this is an ugly integration test. I'll show you later on how to write them better. And after I write the integration test, I also have to write the controller and the repository itself, the one which works with the real database. And in my case, this is Mongo. With Spring Data, the implementation is actually hidden because all I need is to declare an interface, right? And this is pretty much it. If you're not using Spring Data yet, please try it. So the interesting thing and the trick here is that right now I have two methods in my film configuration class, which also has got the annotation configuration. And those two methods are film facade, which has no arguments whatsoever. And this first method needs to call the second one, which has the annotation bin, which means that this one will be actually used in production, right? And this one takes the film repository, because in production, I need the implementation that Spring Data is going to prepare for me, and this is going to work on a real I/O. But here I use the same method with the in-memory repository. And this is crucial. And why is it crucial? Because I cannot test the same module built in two different ways and hope for the best. I need to test as much common thing as possible. So my unit test, should reuse the method that is going to get called when the real module is going to be created in production, and use the same logic except for passing the I/O. So why do I pass the I/O? Why cannot I mock the I/O inside the test? If in my unit tests, I were using this method, so I would call film facade, and I could pass a film repository. The way that it would work is, or actually the way it works with developers, and I've checked that, is that developers will create either mock or use an in-memory film repository if I have one. But what happens next is horrible, because if you have film facade, then instead of checking and verifying the behavior of the system by talking with the system, so talking with the module through add a film and then show me a film or get me a list of films, people will write the interaction with the facade, and then they will check the internal state. So they will verify whether a call was made on the mock, or they will verify whether the in-memory repository actually has got the data that they want. And what happens here is from now on, the module is not black box, is not closed, but you are verifying this internal state of a module. And if you keep doing that, you will not be able to refactor the module. Every time you will change something in a data layer of the module or the data representation of the module, from now on, your test will break, and we don't want that. What you really want is you want your test only to break when your behavior breaks, not when the implementation breaks. So I cannot pass the I/O and either mock or in-memory version inside the test. I need to call a method that has got no properties whatsoever, so this one. But can I actually use mocks for anything? And that there is answer for that. Because I want to test my module, and my module may have dependencies to other modules, I will mock them. And the reason why I will mock them is because, first of all, I am testing the interaction of a single module and the behavior of a single module, which is a vertical slice together with the data access layer and everything outside of it. And the second thing is because my module can also be used as a microservice later on. So I can extract it into my microservice. I already have tests for that. Okay? So if you give people this kind of a setup when they can actually call a facade, but the only properties that they can give to a module are mocks of other modules or implementation of other modules, then developers finally start to test behavior instead of implementation. And you basically, out of the box, you get behavior-driven development instead of test-driven development this way. And you can even go further from this by using events and not using talking directly between modules. But we'll not go into that because let's keep it simple for now. So that is the first problem. People are not testing modules, they are testing too low classes and methods, or too high just the integration tests and the whole system. Now the next problem is actually with having too much distraction inside your tests. Now, the rule here is very simple. We need to keep things, information to minimum, only the most important information from the perspective of this single test, okay? And we need to hide everything else. And the reason for that is because this is hard to read. This is a test from a production, and this is a correct test from my systems, right? The only problem with this test is actually you need to read the whole thing to find out what it does. But if you read only the labels, so these are the names of what's going on, we can see that we should find images by category. Okay, that looks simple. And given there is an image in category X, and there's a lot of code, and there is a Rambo X, I wonder whether Rambo X is actually important from the perspective of this test. And then there is an image in category Y, an image in category X and Y. And after those three images are there, when I search for images from category X, I will get only 2 of them. That makes sense. But this block of code is not very helpful to do that, to understand this. So can we refactor this? There is too much information there. Let me show you how it got refactored and how it works in real situation. If we think about only the important data from the perspective of the test, then these are that I have new images in 3 categories, X, Y, and 1 in X and Y. And I can simplify this by just removing the information and hiding it under the in-category method, for example. And here I'm showing only the minimum information which is required to understand the requirement and the test itself, okay? Without everything else and without any Rambo out there. So here we see the example of the implicit and explicit information. And it's very important inside the test to only show to explicitly show only the information which is important from the perspective of this test to understand this test, not all the information that you can have and not all the information that is there. So for every line of a test, you should ask yourself, is it crucial to understand this requirement or not? So here is an example. If we are testing something and we need the part given, there is a film in catalog, then I can say persisted films first. I do not care which film it is. All I'm saying, it is one of the persisted films. That's it, right? Or maybe I need a film which is a new release. And then what I can do is I can take the persisted films and find anyone which has got new release as a type. This is all the information that is required. I shouldn't build a new DTO every single time, for example. And if I need something more advanced or more complex, then I can move it out using extract method pattern. And for example, when I need I should throw exception when trying to get unpublished article. Well, if this is difficult, let's hide it underneath, create unpublished article, okay? Now, to get that done, to have very simple setup and simple methods, you need to have, for your modules, you need to have sample data, something to test with. Otherwise, you will create it again and again every single time. So what we found is that for every single module, we have a class which would usually cost sample something, sample films, sample articles, or anything like that. And it allows us to do the exploratory testing using the minimum information that is required and not thinking about what is actually a good article, for example. Let me give you a few examples. If I have a test when I need a new article, right? I will call a method. This is a static method, sample new article, and that's it. If I need an article which does not have a title, I will also call sample new article where I have an article having everything filled out and being a correct article, except this time I will tell it that the title is null, okay? And if I need something more, the same pattern applies. I'm hiding all the information which is unnecessary for this test to understand it, right? And I'm showing only the relevant information. And how does it work underneath? Well, underneath there's a method sample new article, which has got properties, which just takes a map, basically. And I merge this map, which means I overwrite everything else from the sample new article map, which has got all the good properties for a good new article. And then I create the object, this DTO object just the normal way, right? Now, why do I use a map? I usually use a map which looks like something like that, just because this map will be reused both in the unit testing, when I am talking about objects, and in the integration tests, when I convert this map, for example, to JSON. Or maybe when I verify whether the JSON that I got back is exactly the same as I put in, or has got the information. So it helps me a lot. Now, with that said, we already have the data and sample DTOs for a module to be tested. Now, how about interactions? And the interesting thing here is that in unit testing, interactions are very simple. You got the facade, you have it, you just call a Java method, that's it. But how about integration testing with HTTP, for example? And the rule here is to extract the common interactions so that they are easy to use. And what I do here is usually, because I write in Spock and use Groovy, I usually move them to traits, which are just like interfaces, except this time they can have state. So my test usually has got some traits which will show me what is this test interacting with. This is an integration test, right? So this one talks with article endpoint, article actions endpoint, and some bio endpoint. And what I do next is this. In an integration test, I need a new article created. So I will call a method from one of those traits, post new article, giving the least possible amount of information which is required. Here it is bio ID. Or maybe if I need to update an article, I will call update existing article with the JSON based on the changes that I need. And maybe if I need to preview, I will have another method which is a preview. And underneath, what I have is this. And this is a trait where I have all those methods, publish, submit, preview, and so on, named in a domain-specific way, something that makes sense, not just the posting and getting, right? And I'm hiding underneath all the drama about what is the content type, what is the protocol, what is the endpoint, for example. And even under this, I also have like a special trait communicating with endpoint, which has got even more to simplify this further. So for example, my asynchronous operation and synchronous operations are covered. And all this is important so that you do not have to think about, when you're testing, you do not have to think about which endpoint should I call, what's the URL, what are the parameters, which HTTP method should I use, is it asynchronous or is it synchronous, okay? And everything like that. These are important questions to be answered by the first test. And after you have the first test, you should refactor your interaction method to have it so that you can reuse it. Now, what does it allow you to do later on? Well, first of all, if you don't do it, the problem is that people will duplicate the code and will write a lot of JSON. They will copy and paste basically all the time, or maybe even worse, they will waste their time on searching for a controller that will handle actually the call. Now, if you have it extracted, what happens is this. You can do exploratory testing, which is just a test that walks like a real user through the whole application to find out something. So this is an article, this is a test which follows the golden path or the positive path of my application to publish an article. And here you can see that I post new bio, then I post new article, then I update existing article, a preview article, and so on and so on. So it's very simple for me to write new tests or diverse and like find and do exploratory testing, see what happens if my user does this or that. Very, very simple, just because I got it extracted. So after we have the data and we have the methods for integration tests extracted out, is there anything else we can do to clean this up? Well, there is this method called show don't tell, and you can easily understand it by thinking about what is the easiest way to understand something. Do you read documentation, for example? Or maybe do you read heavy books, which are very good, but you have time to read that, right? What usually happens, if I wanted to understand as fast as possible the requirements, for example, I would ask you, if you have that knowledge, on using a whiteboard. And you will draw some pictures, for example, and show it to me. And this will be the fastest, easiest way to understand. Now, the question is, can we do the same in tests? And it turns out we can. Let me show you another test from production. And this test is adding a category to a tree. So we got a tree of categories, and we're adding a new category, right? And as you can see, this is a block of code which you have to think about and you have to understand, but it's not that bad. However, if you were using a whiteboard, what would you do? You would most likely draw a tree and draw another one with an added category. That's it. That would be simpler to understand. So can we do it? Of course we can. This is the same test from my projects, but rewritten, okay? And this time what we do is we start with actually showing the tree. So we are declaring a tree which has got the root A, B, C, and D. Then the last leaves are E and F here, right? Then what we do is this. We should add a new category. User wants to add a category C under category G under C at position 1. So we write C plus G at position 1, which is like the simplest possible pseudocode that you could write, except this is a real code. And then we call, okay, now we got the DTO, we modify the category. And what we have after that is we got the category G at position 1. It's counting from 0, right? Simple as that. And it's much more readable than actually the code before. It's show, don't tell. So what on earth is this, right? Well, I use Groovy because I use Spock, and in Spock you test with Groovy. So Groovy has got this method call, which is just a method without any name on the object, right? So I got a category node class, which has got all the declared A, B, C, D, and so on as category nodes. A category node is nothing else than just a string ID and a list of children. And I got the method call, which will actually merge those into a single category node, right? So how do I achieve C plus G at 1? Well, it's also very simple in Groovy, because this is just a method called plus. If I want to overwrite an existing operator, I can do it. So here I have a method plus, which will return add new category DTO. But I also have a category node at position, which is G at 1, which is just something I return after applying method add to my category node. So this is all very simple if you think about it, but not too many people actually go into effort of actually writing this. Now, what happens next is very interesting, because once you have it, it's very easy to go further and like go into all the corner cases and the new features. So after we've added the category, how about moving categories, right? Once again, we start with a tree. Then we say we need to modify a tree. And here I'm just using a method which is called write shift, this is just an operator which basically is you can override in Groovy. So I want to move my category B under F, and then I can just see that the category B is really under F, right? This is as simple as that. Now, not all languages have kind of override categories, so override operators. So for example, if you got pure Java, can you do anything? Well, again, you can. Here I have a test which actually works with the paths to categories, updating articles after there is a change in a category. And here I can show the tree. It's not as sexy, as easy as it is in Groovy, but basically you can see it, that there's a tree which has got the root of C1, and then it's got a bunch of branches, right? I declare some articles which are in those branches, or are in those in this tree. And then what I want to do is I should update articles when there is a change. So to do that, I take one of those branches, or actually this is path to C, right? C2 exactly. And I write a new path, which is just using the same method, path to C2, but this time with C1, B2, and C2. So this is the order here defines the where I want to go. Then I execute this, and what I can verify is that my articles are exactly in the correct categories. So AC3, which was in the C3, right, now is in C1, B2, C2, and C3, and the same, and AC2 moved here. And then I add another check, which is the minimum information that I need to provide, which is paths have not changed for all except these two articles. And this is like the simplest possible test that I can write to show and explain to you what happens when you move a category under another category from the perspective of an article, for example. So is it possible to do everything, to test everything like that? Probably not, but it's not only for categories. If you think about, like, for example, testing your car location, like we are writing a system that works with GPSs and sharing cars, for example. What would you do? You would draw a map on a whiteboard. And drawing a map in ASCII art is maybe a little bit of an overkill for a test, right? But what else can we do? If you think about it, you can do quite a lot. You can work with those cars as positions on a map. So here I have 4 cars declared, and I have their positions. So this is A is a car on T2, on position X2 and Y2, right? And then I get a car at position B here, at position C here, and so on. And then when I ask the system, and I tell the system also that these locations are detected, these cars are registered, but only 2 of them are available. So when I search for cars nearby position 0, I automatically know that this makes sense to have B and A, because no other cars are available, and I need to have them sorted this way, well, because this is the closest one, right? So it's very simple, even if you do not draw an ASCII map, an ASCII art map for that. So this whiteboard approach is just thinking about how would you explain the requirement if you had just a whiteboard and you could talk as much as you can, and see if you can do that, and if you can create a small domain-specific language to explain that inside the test. And you may say that this is an overkill, why would we do it? Well, if it simplifies expressing the requirement, it always pays off, okay? Because you will think later on, after half a year or after a month, or just writing the next test, you will reuse that DSL. So the trick here is just very simple. Remove everything which is distracting you from the requirement and from the clue. Like in this picture, there's not a single object that would take it away from you. You can clearly see there is a person attacking a river, a frozen river with an axe. Something I do every winter, right? Not a single object is distracting you from the essence. And this is the clue of testing, basically, and expressing requirements through testing. So when you look at it, you may ask, if we are now expressing trees as trees and showing it all together, how about just write it in plain English or Ukrainian or Russian or whatever else? And there are actually two types of frameworks for testing. One of them, like Cucumber and JBehave, assumes that you can write everything in plain language. Then you will have some glue code that actually turns this into the real code. And this is how you will express all tests. So this is a DSL, but it looks like natural language. The others, like JUnit and Spock, say that you will have some labels or maybe comments to express it, but basically you will base on the code itself, right? And if you are writing DSLs, why not use the first one? And the reason is that there are advantages of using specs in plain text, that business can modify them, write them, and do exploratory testing. But from my experience of 15 years, business never does that. And the reason why they don't do it is because they are not very good at logical thinking, okay? We are trained in logical thinking. The compiler will never say sorry, but I will understand that. No, the compiler will tell us, and that's it, right? So we have to be trained in logical thinking. Now, the business people do not have. They do not have to do that. They will start screaming, they start pushing. They have different methods of coping with when a person does not want to do what they want, right? So there is no benefit, to be honest, here. With specs, together with the code, it's actually faster to write and easier to maintain. And the outcomes, which is just the test report, is just as readable as in the first case, right? And we don't care that business does not write them because business doesn't write them anyway. They want to call us and just talk with us. So if you think about it, this is just a level of abstraction. You have to be high enough on an abstraction level when you're constructing a DSL, writing an API or anything like that, to show all the, to focus on the important information, right? But on the same time, you cannot be too low to make it easy to actually, you cannot be too high because we'll lose focus, but you cannot be too low because it will be too hard to actually write and interact with the API. So this is why we have all those DSLs, very small DSLs, to test. Each module can have its own DSL because it's a bounded context. It defines the meaning of its own words or the definitions of the words from the ubiquitous language. So after all of that, the next problem that I see quite often is integration testing being very slow. And if I have some systems that have like interact with MongoDB, Elasticsearch, S3, AdWords, and Kafka. And to set it all up, to have like a complete test would be actually difficult. And most often the answer to that from the developer's perspective is, let's add Docker to it. And if we add Docker, it will be simpler. Yes, it will, but it will not be faster. And the reason for that is we are talking with all those systems again and again with each build. And this is too slow. So actually, is there a way to do that, to do something about it? And there is. If you think about it, my application usually on each call actually talks with just one system, external system, which is the database. Everything else is actually just, we are interacting with it, but from time to time in very specific features. So what you can do in that case is take those features, put them inside other jars, use those jars, test them there using only integration tests. There is no reason why you have unit test for Kafka. This is just an integration layer, right? So you put all the integration tests out there inside another jar, and you do not touch it anymore. Most likely you will never need to touch it until there is a new integration with Kafka, for example. And at this point, your tests after every build will not have to fire this up and slow down because they need to talk with Kafka, for example. And for some libraries and some solutions, even integration testing makes no sense. Because, for example, with AdWords, Google AdWords, well, this thing changes every few months. So if I have integration tests, they will fail at some point, right? Or even worse, they will not fail because I have mocked with WireMock Google AdWords, but it will not work on production anymore. So actually, there is no sense having any tests except for manual testing, firing this up, looking at the AdWords UI, and actually searching whether these ads are there correctly or not. That's it. So this should solve the problem of actually your builds being too slow. And just to To show that, I have a microservice here, which is the oldest one. It's got 2 years. And all the unit tests, I hope you can see that, all the unit tests, 474 of them actually, are run under 5 seconds, right? And all the integration tests are run under 1 minute, which is actually quite a bad score, but that's not so, but this actually talks with a lot of external systems, right? And we do that by extracting all those integrations into other jars, which we test extensively, but only there, right? Now, during my presentation, you have seen a lot of actually these labels, like explaining what the test does, and these are Does it work? Yeah, it works. Okay, so you have seen through my presentation a lot of actually labels here. They are not required in Spock, and quite a lot of people do not use them. And some of developers think about, well, if my code is so simple, writing all those tests with DSLs and whatnot, and this is just a single line, why would I need to explain this? This is self-explanatory. This is so simple, right? And the reason why I push my developers to actually do this and encourage them to do this as often as they can, to write the English explanation for the test, is my experience from workshops and from my normal work. This is the case, this is an exercise I do when I work with teams and teach them test-driven development. And what I do here is that I ask them, I give them this user story, actually, and I give them scenarios. This is the behavioral scenarios for a system. I give them 2 of them. This is copy from Wikipedia, right? And I ask them, can you write more? How many can you write? I put them in pairs, and I ask them to write all the other possible scenarios for this feature. And the feature is very simple. You just give stuff back to the shop. Basically, you bought something and you want to give it back because you're not using it, you don't like it, whatever else, right? Now, the interesting thing is that except for one girl and except for my own company, which is an e-commerce company, so these guys know a lot of these cases, all the developers would put themselves in jail by implementing those features. How is that possible? Maybe you have heard about the case with Volkswagen, which was that the diesel cars were actually cheating whenever they were testing them, right? Those cars would recognize that they are being tested and would cheat and actually to lower down the CO2 emission, right? Maybe you've heard about it. And who went to jail for doing this? Was it the product owner? Was it the manager? Was it the top manager of the company? No, actually the guy who went to jail was the developer who wrote it. Even though he didn't think about it, he was just, yeah, you know, there's a requirement, I need to implement that, right? Now, and the reason why it happened was that in US, and it's the same in Poland, there is a law which says that if you implement something against the law, you are responsible, not the company, not the product owner, not the Scrum Master, nobody else. You are responsible and you are going to jail, right? So with that being said, what happens here is that apart from a single girl, all the developers would implement here a feature, which is if my stock is full and I have no more place for a product that is going back, I'm going to throw an exception, right? Because it makes sense. The stock is full. I cannot take it back, right? Now, from the perspective of law, you are required, for example, to take it back. You do not have a choice. So it doesn't matter whether your system works or not. You're going to jail because you just broke the law. So I show this to explain one thing, that we used to have, several years ago, we used to have business analysts. We used to have system analysts, people who would spend all their time writing nothing else but functional requirements and non-functional requirements. We would also have system architects, right? Who would watch those requirements and think about what are the impacts on the architecture. And then we would have, for example, QAs who would write the tests. And now what happens with test-driven development and everything and the whole agile movement, we, the developers, have to do the job of all those people. okay? And developers usually don't think that this is important. They think that the code is important. The code is the crucial thing. So you're going to jail just because you thought that the requirements are something you get and you just implement, and the code is important. So the warning here is this. Refining requirement is very hard. It requires a lot of effort, and it requires a lot of thinking, and you will be tired. And to summarize the whole talk, focus on testing modules, not classes, not methods, not the whole system, but modules of the system. Test the behavior, not the implementation. Prepare sample data for the module. It will pay off when you write the second test. Hide API for integration under meaningful methods, because this way you will be able to reuse it. Build a small DSL to express your requirements, just as using a whiteboard. Because think about how would you explain this using a whiteboard, and you will have marvelous effects. Extract code that runs slow and put it into jars and test it there, so you do not have to pay the price of having slow code on every single build, right? Think about that tests and specifications are requirements. Whenever you're writing a test, you're defining a requirement there. And expect writing requirements and thinking about requirements to be a hard job, which is why it will help if you will first write it down in natural language, just to find out that what you thought makes sense from the code perspective makes no sense from a business or logical perspective if you write it down in pure English, for example. So that's everything I have for you today, and I would like to thank my team for using this approach and refining it actually during the last 2.5 years when we are working together. Thank you. Now, usually at this point there are questions, but the problem is I have a flight to catch. So here you have all the data you need to send me the questions either through LinkedIn, through Twitter, or through email, and I'll be happy to answer. But unfortunately, I have to catch a taxi and go to the airport. So maybe questions next time. Thank you.